So thanks for coming. My name is Renah Wolzinger, my partner in crime, Keith. And Keith is actually a commercial airline pilot who went back to community college to take a digital media program and completed a 24-unit certificate to do broadcasting. He appears on CNN and other international channels as an aviation expert. And my job at Golden West is I'm a digital media professor. I've been the chair of the department for a while, and now I'm full-time with WestEd. You might know me from the launch board doing data stuff. But this is my first lab. I've had an audio company since we opened in '92, Renzone Music. And what my company's done is audio and video, recording, producing. We're involved in the Grammy organization for all of these years. And I did that by going back to school as well and learning recording engineering back in the tape days and the ADAT days before all of this computer stuff happened. So, what we're going to talk about today is how to record good audio on anything. So we're not going to talk software specific, although I'll go over some options that I know about over the years. But what I've found in all of these things, just like Sean is talking about with video, is students use anything that they get for free to start with. And so if you want to just show them how to do stuff, you know, with video or audio, and they might not have an Adobe subscription, and you can tell them to do it, but they record on whatever they have. And so my goal in teaching has changed over the years to be as much software unspecific as possible, although I do teach an online Final Cut class which is specific to that software. But in the audio world, it's easy to be very non-specific because the software itself is very similar. And in fact, the people that do the programming go from company to company, so the software over time becomes very similar. So, okay, so being a digital media person, I put this on my Google Drive already, so that's the link to it. So if you want to download it right now instead of waiting, you can do that as well. I do everything through Google Drive because I got tired of servers and people not showing up to school and all of that. So Google Drive is like people email me, it's like all your stuff's on Google Drive, so get on there, no excuse. So are we good? So that's QG4MJEY. Yes? Yeah, go back one.
Do you have to like share it with others, or do you create like a public?
I put share, and then anyone with the link can view. Okay. Although if I'm doing colleague work, like with my professional colleagues, then I'll put anyone can edit. But I never do without my students because they just kill all my stuff immediately and like put other stuff up there. So yeah, just make sure that you check the share option, or they're going to say they can't find it. And that's when I first started doing it. You know, they're like, I can't find your stuff. So okay, are we good with that? Okay, so the first thing is where you should record, and this is really important. We started our business in a house that was like one big open rift. We could find our children wandering around in there. And we found out that it was pretty horrible for recording, and we were spending a lot of money in recording studios. So we moved, and we had the opportunity to convert, which would have been a garage, into a recording studio. And what we found out over the years is people have made this almost a free thing where you don't need to build a $100,000 room. You can go and have a little thing called even just a vocal shield if you're just doing like vocals. So what we do, and I should let Keith talk about this part because he does this when he broadcasts internationally on these news channels. He uses this stuff for his recordings. So let me have you talk about that.
So when we're talking about sound isolation,
go ahead.
Just talking to your microphone.
It's okay.
What we're talking about is so that we can hear only your voice and not the trash truck going down the street or the lawnmower from the gardener, because you're going to be doing this probably at home, and it's critical to find a place that's first quiet, and second that you can record only your voice and not other things around the house. Room echoes in particular are a problem. If you're in the bedroom, sound echoes off the floor, off the walls, off the ceiling, and it causes reflections which distorts your audio. So you want to have as clean an audio path to the microphone as you can. Two good ways are shown in this picture. The microphone is in the center of the picture. In front of the microphone, you have a pop shield that takes out some of the sounds that our mouths naturally make when we speak, so that it sounds clean. And then the vocal shield goes behind the microphone, and that takes out some of the room reflections to leave the straight path between your mouth and the microphone with nothing interfering. We'll switch to those right now.
Sure. Yeah, I'll do that. Glasses for that.
Yeah.
And for webcast. This is how I do my online as well. So what I do, is that how you want it?
Yeah.
What I do when I do my videos, I do like 16 videos, and they're like 45 minutes to an hour each. So I bought a little stand, a short one, and then I just put the vocal shield in front of it, and then I have my mic sitting right there. I have a condenser mic. I'll go over the mics in a little bit, so that I still have that sound isolation right in front of my voice, and it sounds like studio. It's amazing. But the vocal shield really is key. Of course, we have also a room that has some treatment in it, but it's really 90% that vocal shield, because you could just sit it on your desk. They're pretty big. They're like this tall and they go around. So, but you need to get a shorter stand. So one time. So I'm talking, and then I'm capturing what I'm doing on the screen. No, they don't want to see my face. So I'm like, you want to see my face, go to Renah.com, but other than that, they don't really. I started thinking about that, like, do I want to have my face in the corner? And then I just thought, one still image of me when I was 29 was like perfect, so I just left it in there. See, this is girls in IT, the way the girls do things in IT section. So, all right, go ahead. Go ahead.
So what's important is have a microphone on a microphone stand, freestanding, not a little desktop.
Did I just say a desktop?
Picks up all the sounds that your
it does pick it up.
Makes. And you'd be surprised. Who's tried a desktop microphone sitting on a desktop?
That's what I do. It picks up all your mouth sounds.
It picks up every click on your computer, every type you make on your keyboard. It picks up a lot of mechanical stuff that resonates through your desk, and that's bad for recording. So get a microphone, something like this, anything, you put it on a microphone stand that's separate. What? Yeah, hopefully you have a before it's doing pretty good.
Yeah, that's a problem.
But the important thing here, and this is from Prime Acoustic, this is one of the manufacturers that makes these types of vocal shields. So the open microphone picks up a mix of direct sound from your mouth and reflected sound from around the room. But with their box guard is the Prime Acoustic main board. It blocks the reflected sound, so sounds are blocked from coming off the walls, off the ceiling, and the only sound the microphone's going to pick up is what comes from your mouth. So that gives you the purest, cleanest sound you can get into your computer. Yes? Well,
it's how you do your podcast.
Yeah, that's the best way to get recorded audio. But you're going to be doing this at home, and your computer will be off to the side if you're doing something. But
it's kind of hard because you have your microphone still kind of in front of your desk that way. But like I do a desktop one, but I get all the sound in my videos. And he has a podcast that he can't have that, so he has a four-standing mic, and it sounds perfect.
So, but you don't have to be in that position. You can have your computer here with the microphone stand with the mic next to it, so that you're at sitting level and speaking into the microphone that would be next to your desk. So you don't have to be like away from your computer. This is like for a studio broadcast situation in that picture. Yeah. I haven't. I know people do, and like for gaming, those kind of headset mics.
I never have either. subjects are talking to each other and they're listening to each other. So in this situation, it's just
those are $400 headsets. You see those guys standing in the studio and they have the basketball games. Those guys use that because they have to monitor themselves also, and it's a very noisy environment for them to listen to themselves.
But podcast, don't you have the in-ear? Yeah, he has the in-ear from the producer, who's in New York, by the way. And then his lavalier mic clipped on. So it's the same situation, but you can't have the whole headset on camera in that case. But yeah, I'll go over mics in a minute, but definitely, yes. Yes, and I'll go, okay, I'll do mics next. You guys are all, that's really good questions. Are you done with this part?
Yeah.
All right. So I just want to say something really quick about acoustic panels. What I did, you can go to like Home Depot and get those white 4x8 sheets, and they're just like $5 or something. And then acoustic panels run $40, $50, and you just glue them to the white stuff from Home Depot. Then you can put them up with like a nail. So because the other way to install it is to glue it on your wall. So if you're teaching, you know, you don't want, it's okay to have 4 nail holes, but you don't want to glue that all over your wall probably. So if you are getting a lot of weird sounds and you have the space where you do it in, you can just use that method, and that's what my students use as well in their apartments and stuff. So, all right. And then the other thing somebody asked about floors, I've done all kinds of tests with floors. If you have wood floors or tile floors, it's going to be very reflective, and you'll get weird reverb. It'll be, what you can do is just clap. If you hear the clap again, it's bouncing off the walls, and then if it's real dead, that means you've solved your problem. All right. So now, what do you need to capture sound? So there's a few things. This is one of my favorite things ever, the Zoom H4n, and it's basically a little recorder that records full quality audio, or MP3s, and it holds a lot of data. What I like about it, you can plug microphones into it. Say you don't have anything to record into and you're just doing audio, and maybe you're not doing video, you can get what's called an XLR cable. And I just bring a B, which that's a long one, 3-pin cable, so it's grounded. You just plug it in here. If you want to use a handheld mic, or you can go into these condenser mics here, which gives you there's 2 of them, gives you a stereo field around this recorder. And so a lot of my students come in from high school with the little cameras, right, the DSLR cameras, and they're like, audio. I'm like, that's kind of reference audio in your DSLR camera. It's a recording video, so I had them get a field recorder. They're between $200 to $400 or something. When I first started this, they were between $500 and $2,000. So I said, this is like, you guys are lucky. You came in a little bit later. And if you go to any movie set, you'll see it all over the place. This is capturing audio all over that as well. So this is a kind of industry standard, or yeah, one of the industry standards, Zoom, for recording. It does up to 4 channels at the same time. So that's one way. And all you got to do is, this is really important. There's meters on here. And the way to screw up your audio is to not understand meters. And the way meters work in audio is the top number is 0. If you go above 0 in digital audio, oh, since this is technical people, I can actually do this. You're recording this. As soon as you hit above 0, you're recording this. This sounds like, this is what you get, clicking. So as soon as you blow 0 in the digital world, you just get clicking that's unfixed. So the first thing in audio is don't blow past 0. There's usually some headroom there. But -6 decibels is where you want to record everything. And then leave a little bit of headroom, which is 6 decibels of headroom. It's really important because you're going to get just distorted, crappy sounding, clicky audio that doesn't sound right. So all of these devices have meters, whether it's software or a little device like this, where you want to do a sound check, and they'll have like a kind of sound check mode where it's flashing or something. It's on record enabled, but it's not recording yet, so you can check your audio. And then to sound check it, you have to do your loudest sound. So if you're going to be screaming in your video, if you're screaming at your students, then that's what you want to do here during your sound check. It's going to be your loudest time that you're doing audio. So yeah, so right here, what you're doing, you're recording your analog sound waves from my voice, and it's getting digitized as a sine wave. Right. Yeah, it has a lot of built-in effects in it that you can turn. So if you're recording something that's super dynamic, like in my classes, we do audio post-production for movies. We do like motorcycles and engines and stuff. You can turn on a limiter, which will say don't record anything over 0 decibels, and so loud stuff will just get compressed down, which it just takes the high peaks of the waves and compresses them down so it doesn't blow 0. You only use that if you need to, because it's gonna, it's not as clean audio path when you add that into it, but you have to do it. Like I do that with opera singers as well, like stuff that's just so dynamic that you're gonna peak. Right. So what he's talking about, I don't know if you guys can see any of this. Is some variability with the compressor. What it does is it evens out the audio so that you can make it all louder. What it's just essentially doing. So if you have quiet passages that you don't want to just raise noise up, you can use a compressor and then raise the gain. That's a whole nother class. That's like 2 classes. Yeah, that's it.
Correct, yeah. I also do a podcast. I interview people, so I use this to what we call field recording. Those of you that know what that is, that's great for that purpose.
And that's why the microphone's good, because you can plug it in and then go back and forth or have 2 of them. So he can have his guest have a microphone, and then do you monitor on headphones? I think you just do a sound check. So, but if you're doing like film, or someone will have headphones on here and make sure that also you're hearing that it sounds good while it's recording. So then the next thing is microphones. So what kind of microphones do you use? I brought the most common microphone in the world, which is the Shure SM58, and I'm going to go to the Shure side just to show you, because I have it up here. Maybe I don't. Oh, I have this one up. So Shure, what's nice about it, without knowing anything about microphones, they have all their manuals online for free for every microphone. What do you use them for? How much they cost. These are like 99 bucks, and what's nice about them, especially for students, is if you drop them, the grill gets dented, but the microphone doesn't. Nothing happens to it. So it's I have like a whole box of these things myself, and at school we do too. These are nice because you really don't screw up your audio with this. You can have really loud stuff, and it's what's not is not super sensitive. So if you want to be super accurate, this isn't the microphone to use. This is like what you can do your lessons on these. So they're like just really rugged and not expensive, and then you can put it in a little mic stand, which is what I do. But there's some other really cool methods. This is my favorite. You want to talk about this? This is your deal you found.
Sure.
That's from the NAMM show.
Let's look at USB microphones first, and then
okay, go ahead.
we do this.
I'll put it on Yeti.
Yeah. So, the way probably most of you get audio into your computers is with a USB microphone. The microphone built into your computer, if you have a Mac, is a USB microphone. But generally, you take a USB microphone, plug it into the USB port on your computer, and then select that in your system as the audio input to do your recording. So, common one, pretty good one that I use a lot is the Blue microphone Yeti Pro, made by Blue Microphones. They make a whole series, the Snowball, but we've had pretty good luck with USB microphones made by Blue. But the USB does have some limitations to it, and using standard microphone with XLR cable does give you better sounding audio. The problem is you can't plug an XLR cable into your USB port on your computer. So the way to do that is to get XLR to USB converter. Now you can show them, such as the Shure X2U that I live by. Because the quality of the audio you're going to get from an XLR style microphone into your computer is dependent on the quality of the converter that you're using. So there are some really cheap converters out there that don't do a really very good job in converting the XLR audio to USB audio. The Shure, it's a little bit more expensive. It's about, what, $125, I think? Oh,
From $99.
They dropped the price. Yeah, it's $99 now. And it's got a lot of settings on it. It's got gain. You can monitor headphones. It's got a headphone jack on it. So you can monitor your signal.
Basically an entire recording studio. Because it's got a microphone preamp, a headphone monitoring. And so students that have nothing, they get this and one microphone, and they can record professional sounding audio.
And then you have the magic USB that you can take this microphone, plug it in right here.
Or I brought a cord too. Oh yeah, do it that way.
Yeah, this goes in there. This goes into your computer, and now you've got fantastic sounding audio.
With any mic.
With any mic that you have in your studio plug.
Let's speed it up, that.
Oh.
We'll put it in there.
Highly recommend. Heck to you.
So yeah, we've tested a lot of them. This one had the best. So yeah, that's another good line. This one is, as far as just a converter, kind of just the most solid. You can feel it's a solid piece. Now Blue makes one that's like a shell, and it doesn't sound nearly as good as the Shure does. Even though I like that company, but just for this product, it just works. It's one of those kind of hammer and nail things that just kind of works. Some in your toolbox. So my students run these in different rooms because they want to get away from the other students to record something and bring microphones or borrow some from school and go do their thing. So what it does is it frees them from the desk, because we have M boxes at the desk, which are little 2-channel microphone audio to digital converters. But now they can go run around and record wherever. Yeah, we also have the Zoom site up here, so you can look at the H4n products if you want to look at those as well. So some other kind of microphones that are really important. I prefer to record with condenser mics or USB mics for lectures or broadcast stuff. So that Yeti Pro sounds fantastic, and that it's a USB mic, but the condenser mic that I use a lot of times, they're more expensive, and so a lot of times, it's an investment. But I use Shure just because it just works and they don't break. So there's one called a KSM32 that what it does, it's more sensitive, and so it'll pick up your voice really well. But if there's any other noise in your room, it'll pick that up. So you have to be careful with those condenser mics. But I guess the easiest one to use is really the USB mics or the dynamic. Oh, that's true. So, and I didn't bring the Yeti Pro, but you can go straight XLR. There's a little XLR connector on the bottom of that, so you can go straight to XLR, which actually is a higher sounding quality than USB. So somebody asked about boundary mics. I've used boundary mics, but the volume is lower on them. So as long as you can have a quiet enough room to get the volume high enough, then they're fine. They won't record kind of as deep in quality as like the bigger mics, so they just don't have the, if it's a dynamic, they don't have a big enough diaphragm or enough action like a condenser mic has to record that low part, and that's why I don't use them. I try to use the biggest mic that I can for that kind of big resonant sound when I'm make my voice sound important as a teacher, so I seem to do something. Right. So I'm kind of in love with two companies for lavalier mics, the Rode, R-O-D-E, which are made in Australia, and they're a little bit less expensive, but they sound really good. And then the other company is AKG, and AKG has a lot of them that are like 99 bucks. And you need a transmitter and receiver, so you just wear your transmitter on your belt, and then plug the receiver, I guess, however you're getting it into your computer or wherever you're recording it. So that, that's a little bit more expensive to get the transmitter and receiver. The mic stuff is not expensive. It's usually the transmitter and receiver package. If you're going high end, go Sennheiser and spend $1,000. Yeah, so just steal that. Yeah, so if you already have the packs and then you get the lavalier, then you're all set. And then just, you know, it's going to rustle against your clothes, so you have to practice a little bit how you want to wear it and all that. But it gives you that freedom of running around. And then you can do, I guess you'd probably be going, you could be going USB into your school computer. I don't know how, there's a lot of ways to go in. The gain is just real low, so that's, yeah, that's why I don't use those. I use those for totally different things, like inside of drums, or I keep them in the drummer's chest for the drums, like different things like that, but not not for vocals. Yeah. Did I forget any? So yeah, I put boom mics up there just because it's another, those mics that you see on your cameras. Sometimes that's not for doing both voices, that's mainly for kind of recreating something you recorded on your video or in a production and then adding sound later, so I just threw that up there. But any questions about microphones? I think that's another like 2-week lecture. But yes. So ribbon mics are mostly used for really loud stuff, to be honest. They're super accurate, but you have to put the gain really high for them to work on the lower sound. So trumpet players exclusively record on ribbon mics, for example, in the recording industry. And for a vocalist, if you use them, it's got to be in a real quiet studio because you've got to turn that gain up pretty high to get that sound from the voice. It's just the sound waves pressure isn't strong enough to activate those ribbons without a lot of mic pre. So I don't use those for regular talking stuff, but I will use them with a dynamic singer that's very loud. And that's the only time I'll use ribbon mic. Ribbon mics are they're the most accurate reproduction. So, but you have to have a studio environment really to get good stuff out of them. So now I use Royers 141s. They're great. That's right. Mm-hmm.
And what I find is people don't know how to hold the mic.
Right.
And so where is the right spot to hold one for optimal audio? Because people hold it side.
Well, the problem is usually they give you the wrong mic. So what they usually give you, and they usually don't have these, but they'll have the sister of this, which is a Shure SM57, because they're a little bit cheaper, and not knowing that's not really for vocals, it's for instruments, and they look like this. And so you hold them, and when you talk, Keith was talking about the vocal shield or the pop filter, which is this. It sounds like you're spitting and all over your microphone the whole time, like, so that's what you hear, because it's really made for instruments where you're not spitting, you're playing it, right? So for one thing, now you have this on, it doesn't sound like that. And now you have to have a mic that's called a handheld mic. So if you have one of these, it's going to have a base that's super solid to hold it. You never touch this, and you never blow into it. And so, you see like people doing that. They're trying to get an effect which is called a boundary effect with the extra lows. But, people don't know. So you're only supposed to touch this part if you're not getting extra sounds on it. But a lot of times I'm on these two, so you either use or it's feedback all over the place because it's not loud enough, and the frequencies are causing problems in the room because the room doesn't have sound treatment. It's just bounce together and make, feedback. So, but that's it. So when I sing, that's what I look like. Well, this is a dynamic mic with a cardioid pattern, which is only can get me here. As soon as I'm here, I'm off mic. Or it's a cardioid. It's like 30 degrees per side, and then only about 3 inches away. So even here, I'm off mic with this. Now a condenser, I could be further away. I am going to get more of the room now, but it's going to pick me up because the condenser's already charged. So as soon as it gets a sound wave, it's going to pick it up whether you're close or far. Where this is a diaphragm, so it's got to mechanically move. That's probably too much information, so just ignore it. Right.
what can you do if you can't get that person to put the mic somewhere near their mouth? I mean, you said something now I didn't hear before.
Right.
I guess I missed that part. What is that?
So I'll bring it up here. You want to talk about condensers for a minute, and I'll bring it up. Talk about how we set up the condensers. I'll bring up I'll show you a picture.
The condensers are better microphones, but they're a little bit more complicated. It requires some internal power to run them, called phantom power. Who's heard of phantom power? Okay.
There we go. There's a condenser mic.
Thank you. So condenser microphones are better, so they require that it is deployed into some sort of unit that's usually a 9-volt battery. Powerful.
So again, too technical, but you need 48 volts to run this thing, and it's just charged up, and waves hit it, and then you get like it's just a mathematical equation, capacitance and voltage, and then that reproduces sound versus a mechanical thing. So those are really sensitive, and that's what they're designed in England to get that kind of nuance of your voice instead of everybody's voice sounding the same, which is the conference microphones that everybody's voice kind of sounds like whatever, but this really gets the nuance of your voice. And so if you're doing some critical recording, they're much better mics, but they are much more expensive. So around the $500, they go up to about $3,000. Yeah. And also you can't, that falls into the holding question. You have to mount this on the shock mount, because if you touch them, it's going to make really loud noises. That's how sensitive they are. You can't touch them.
They're not handheld microphones.
But they're awesome mics. It's like, so everybody who loves microphones buys they have all their favorite ones, and that's it's a. Yeah, you can get those as well. It just depends on what, it's all just like guitars, what do you need to sound like? It's just up to you, right? So for most of the stuff that you're going to be doing especially for lectures and things, the USB mic is fantastic. That USB Yeti, I could highly recommend it. Or just a $100 Shure, fantastic. Okay, so formats. Did we skip one? Yeah, that one. I think I talked about this briefly, but here's my picture of it. So VU meters here, every device you have or software you have, whether it's GarageBand or on the PC, I've got a whole bunch of, I'm thinking in my head also, but Logic, Premiere, any of those things, they all have these meters, and so what you have to do is just make sure that they're not turning red, which is over 0, and so that's what they look like. And that's just something I know my students get confused because they're negative to 0, and your lifetime usually meters don't look like that. So 0 is the stop dead point in audio. So it's kind of backwards, and headroom is just the difference between where you're recording and 0. So you want to leave 6 decibels of headroom in there. All right. So audio formats. You want to do this one? Go for it.
So, most common audio format you've probably heard of, the last few years is MP3, which is a lossy format. It's good for making small file sizes when you record. You can record 15 minutes of audio, and it's roughly an 8 megabyte file. So it's very efficient. It can take a lot of information and make relatively small file sizes. So if you're recording in an hour of audio, you might have maybe a 30 gigabyte or a 30 megabyte file. So it's still very, very small. With some of the other files, AIFF, with AIFF is roughly the CD audio file format. But the CD holds 750 megabytes of audio in an hour, so you can tell that it's less compressed than an MP3 file would be. Now, granted, those of you that know, you can select all kinds of bit rates and different rates of capturing the audio in MP3, and so If we're talking for an MP3, say, I don't know, even a 320 kilohertz audio rate, it's still a pretty small file size. But when you're talking with AIFF, you're talking about 16-bit 44.1 capture rate. It takes up a lot of space, as does WAVE, which is fairly compressed. AC3, you want to talk about? AC3 is what we know as local digital audio, which you can make surround sound files from that. Everything else is stereo channel, but if for some reason you're going to make I'll say DVD is all encoded in AC3. If you're recording on the DVD for some reason, which you would if you need a lot more disk space than on a CD, like the standard DVD is 4.7 gigabytes. So you can record a lot more on the disk. You're still using disks.
I don't think anybody is.
Anybody, you record a DVD, still okay when you think audio only or video?
So what I want to say about this is what is your output? So if you're recording, if you want kind of natural sound audio and you're setting up any of these things, it's going to ask you, you have to know a couple numbers. Okay, so numbers you have to know, first of all, are sample rate, and then two sample rates are commonly in the world, 44.1 kilohertz and 48 kilohertz. So you have to know those. 44.1 gives you, it was really created to represent what's on a CD, but 48 kilohertz is what is burned into a DVD or Blu-ray, because that covers your audio spectrum of where most of the sounds are that we hear, between 20 and 20,000 kilohertz, which you're going to have to remember that. But 48 kilohertz you want to set. If you're using any software or a box to record on, and you've got to know like which number to pick, and you have enough to pick 48 kilohertz. And then the other two numbers you have to know is how long is your digital word in your recording device? Is it 16 characters long or 24 characters long? So 24 gives you that full audio. 16 truncates it down and it doesn't sound kind of interesting when you record something 24-bit, and then you compress it down to 16. It sounds like pretty bad, but that's what we're used to hearing on CDs. So for those of you who are my age, all our albums sounded better than CDs, right? Because of that. So thing right there. So 48. If you record 48 and then keep it in 24-bit, it's going to sound what I kind of grew up with listening to, you know. Okay. So a couple numbers you need to definitely know those in any of this recording thing, at least sample rate and bit depth. The 48 or 128. So that's a higher one, so you can record up to 192 kilohertz. So if you've got like a Blu-ray or just your streaming and you've got broadcast audio, you can go all the way up to 192 kilohertz. So if you're wherever, what is the output and where is it going to be heard? You know. So like if I'm doing like a lesson for my students, I can be in a lower one. But if I want to broadcast or record a Blu-ray or do a movie or something, then I can go to 192. They're actually the most common use for everything. 192 is used to press it down, you know, to press it down for the final product. So it's to get the cleanest audio possible, but it's not usually exported that way. That's just during the recording, then it's compressed for exporting back down to 48. Right. Right. Well, the biggest difference that I hear is between 16 and anything else. because that 16th is not, it doesn't sound very good to me. When I record a band and go down 16, it's just all the nuance is gone, and so that's where the biggest difference is. Absolutely. So the more, just like in video, when you record the 4x4, same with audio, the more audio information you have, the easier it is to work with later, because you just have more digital information. And so that, that, although you may not hear it, but yeah, if you had something you wanted to just tweak, then it's easier to deal with it with more digital information. Just like color. Color is exactly the same way. Yeah. Tony said with 4K, right? Tony said record in 8K, and like, even if you're going to 8K, because then you're going to have all that color to work with and all the light to work with. You can record in the total dark, and you can fix it. So that's kind of the thinking today, is record any of this audio video with the best you can get, and then your export is your export. But you also have your master, which Sean talked about with his stuff. You have your master, not high quality. So tomorrow when everybody has 8K TVs, you'll have a new master, so you can remaster it. Any other slides there? Over all the time.
320 for higher.
You can put it. I want to finish this.
Yeah, but that was his question.
Let me finish this. Okay, editing tools. I'm not going to go into this. This is part 2 for the next conference, I guess. But there's a lot of things you can do with your audio after record. We talked a little bit about compression, but this would be things to enhance your audio or fix it later. And you need software usually to do this, and that's a whole other topic that I'm not going to have time to do today. But I did have a question already about some of the softwares. I've used all of them. I started teaching 10 years ago on Pro Tools, but it's kind of expensive, and we kept having to change hardware to school all the time. So we switched to Logic because it just worked on everybody's computer. We use both. They're like the same now, and people do Adobe Audition. I'm like, I don't care. I'm like, just bring anything in. I don't care. If it's GarageBand, you can do the assignment. They all do the same thing. They all have a track. You can record on any of these mics into it. They all have meters. They'll get a waveform. So, and they're all super easy to use now, where you hit like record. So this is me recording our lecture right now about audio, and I'm getting the audio signal, and I'm looking at my thing here, and I'm not bypassing 0, and I get my wave, and that's it. So there's not really a need to, in teaching this stuff, like a special software. But the reason some of them get this is for post-production. There's thousands of loops and sound effects that come with it, so the students don't have to go to a library or something. But as far as making a track and recording a track is the same in anything, Mac, PC, whatever. It's just a waveform. It's not nearly as complicated as it's just extras that may come with these different softwares. So it's simple, and it looks the same even on this. You just hit record and you get the same waveform and the same VU meter to 0 decibels. So. GarageBand now, I want to say something about that too. GarageBand and iMovie look the same now as Logic and Final Cut, and they're on the compatible engine. And so what my students do is they come in, they already know how to use it like they're in kindergarten, and then I'm like, here's all the other 90% that's hidden that they open up. And so that's what those are. That's what they're built for. Consumers think to sell millions of licenses for Apple that wants to make money, right? I'm not advocating for Apple because like I said, there's just, I don't really care what the students use, whatever they want. Yeah, oh my gosh, Cool Edit Pro, yes, I do remember that. All right, we have like 3 minutes. Okay, go ahead.
I was going to mention a little bit about how to hear your audio once you've recorded it. I like using SoundCloud. I think of it as YouTube for audio. So there's a ton of things on SoundCloud, and if you're posting a lot of audio projects, where do you post them? SoundCloud is a really good solution for that. You get a free account for, I think you're allowed 30 minutes of audio on a free account. Above that, they have tiered pricing for more. But it's a really good way of sharing the audio that you're recording and getting it out to students, class, friends, the world. Just think of it as YouTube for sound.
One of the other things we found about is if anyone WordPress, it's just like YouTube. You are looking at your body, contact with. So it's just like YouTube.
So we're down to 1 minute, which just gives you an entire minute for questions, other questions and answers. Kept it short on purpose. So there's a lot of stuff online about this, but feel free to contact me at any time. I also have a website and videos and all that, and I have cards up here. And just that, you know, audio's been my life. I'm a clarinet player. That's been my profession for any of this stuff, and so it's been added on later. So I love to do and collect mics and have the studio, and it's just an awesome thing. And so I use it a lot more than just recording lectures. But so I hope that helped you out a little bit with what you're trying to. So.